Hey there, Lions. Today we're going to do another lab activity that is going to answer the essential question of if the potential energy of an object is increased, how will it affect the distance another object travels when hit by that first object. Today we're going to use a wrecking ball method using a ring stand, some string, and a bead, and a little bear to see how far that little bear can travel. The first thing that we're going to do is figure out the mass of our ball because we know that potential energy depends on mass and height. So this bead weighs 5 grams. We also need to know how much it weighs in ounces. It's 0.175 ounce. Okay, so what we're going to do is we're going to make sure that our bear and our ball are always in the same position, so when we're measuring, it's an accurate and fair measurement. So in our chart, we see that we have to raise the wrecking ball by 5 centimeters, and we're going to do that by pulling back until it's 5 centimeters off the ground. Handy little ruler. So we just put the ball right next to it, and we pull back until we see it's at 5. And what I'm going to do is I'm going to release the ball and measure how far he travels. So I can come over here and use my ruler, and our first number is 14 centimeters. Okay, set it back up again. Make sure that ball's going to hit him right in the back. Pull back to 5 centimeters again. $14 centimeters. Make sure it's set up again. Centimeter side. Oh, didn't go far that time. That's okay. 4 centimeters. Now what you need to do is average those 3 numbers. And we just hit stop.
Yeah.
Okay, so we finished the first column. You got to find the average on your own. So now we're going to move on to the second row, which is 10 centimeters high. Think in your head, what do you think? Is the bear going to travel farther this time? Or is he going to travel the same amount? Let's find out. Same process. Pull it back till it's 10 centimeters high. Then let go. He went 15 centimeters. So I'll write that down. 15. Don't forget your labels. Second try. Oops, had my ruler upside down. That doesn't help. 10 centimeters. Make sure I'm lined up. Oh, I didn't hit him very good. I'm going to try that again. I'm going to get, I can get that up to 10 centimeters. Oh, that was a good hit. Let's see how far he went this time. 28 centimeters. Okay. Set it up. And do it a third time. Whoops. Back over there, Mr. Bear. Make sure I'm lined up. Okay. Whoa, he traveled really far this time. He went 33 centimeters. Okay, pause the video and find. Okay, so now we're in the third row, raising the ball 15 centimeters. So, use my ruler. 10, 13, 14, 15. Making sure I'm lined up. 27 centimeters. Okay. $31 centimeters. Last one. $37 centimeters. Pause the video, find your average. All right, we're on the last row, so we're going to raise this ball up 20 centimeters. The independent variable is the question right after this, and I hope you see what we're changing every time is the actual height of that ball. It's not anything we're measuring, it's what you've been told to change. The dependent variable is how far that bear is going to travel. It depends on how high the ball actually goes. That's how we can tell the difference between independent and dependent. Let's work on that 20 centimeter height. How far do you think it's going to go this time? Don't drop it. That looks about right. All right. 34 centimeters. Make sure Mr. Bear's lined up. Go. Wow. This time, he went 62 centimeters. Okay. Last one. 67 centimeters. Now what you need to do is make sure you answer the questions on your lab sheet.